Hello, today's lesson is going to be about how to factor trinomials, and this is day number 1. Our objective is to be able to factor quadratic expressions to reveal the zeros of the function that it defines, and zeros is another fancy word for x-intercepts or solutions. Could you go backwards and take apart a trinomial, such as this one right here? In the past, we factored binomials, and we've also used an area model to factor 4-term quadratics. But now we want to know, can you factor 3-term quadratics when you don't know exactly what to write into each of these 4 spaces? Eventually, our overall objective is to be able to have you do this symbolically, but we're going to start with a visual model if we can. So the first thing you do is you check for a GCF, especially if there's a negative GCF, and you reverse distribute if you need to. In this case, I know that my GCF is going to be negative because the coefficient in front of x squared is negative. And I ask myself, what divides evenly into -2, -11, and -5? The answer to that question is -1. And then I'm going to reverse distribute by dividing this out of each one of these terms. I'm only writing this for instructional purposes. You don't have to. A -2 divided by a -1 would be positive 2x squared. Plus 11x plus 5. Now this GCF does not get written in the area model. I'm only concerned with factoring this expression. However, I'm still going to write it in front because that GCF was part of my original expression in the first place. But now I'm going to write the first term here and the last term here. There's no question about what goes in those 2 spots in the area model. But then I'm going to ask myself, what multiplied by what will make the first term? That's this guy. What multiplied by what makes 2x squared? 2x times x makes 2x squared. And then I'm going to make a list of factor pairs for the last term. What times what makes 5? Well, 5 is a prime number, so the list of factor pairs is going to be really simple. It's 1 times 5. Eventually, we'll do more complex examples where this is not a prime number, but we'll get to that on day 2. So then I have to do trial and error with these factors, with the pairs of factors, I should say, and the signs until you find the right one. And what do we mean by signs? Well, we mean whether or not they're going to be positive or they're going to be negative. Is this going to be a positive 5 and a positive 1? Or is this going to be negative and negative or some kind of mix? Well, if I have a plus 5 here at the end, then positive 5 and positive 1 will multiply to make 5. Or negative and negative. I'm going to do positive, positive because that's all that I have here. A negative wouldn't make sense in this case. And again, the GCF doesn't have anything to do with this factoring for the area model. So I'm going to choose a positive 1. And a positive 5. And I'm going to see if this works out. 2x times 1 is 2x, and 5 times x is 5x. Now, how do you know if this is correct? Well, what you have to do is you have to look in those spots that are diagonal in the area model, and you have to ask yourself, is 2x and 5x, when I combine those like terms, what do I get? I get 7x. Does that match the middle term? Does 7x match the middle term of the trinomial I'm trying to factor? It does not. Therefore, I'm wrong. No big deal. I'm going to try switching them and see if that works. If I switch them, I would have a 5 here and a 1 here, which is going to change these 2 terms. 2x times 5 is 10x. X times 1 is x. And now I ask myself, on the diagonal here, when I'm combining these like terms, now I have 10x and 1x. When I combine those like terms, 10x plus 1x is 11x. Does that match the middle term? Yes, it does. Therefore, I know that this is correct. So what are my 2 factors that I'm going to split this up into? 2x plus 1 is the first factor, and x plus 5 is the second factor. That is how I write my answer as the product of two binomials. These two binomials, and of course the GCF is there because it was part of the original expression in the first place. We're going to stop here and go on to the next video.